Hey, everybody, how you doing?
Doing well.
Good.
Are you working it? You working that homework? Got that report coming up and other stuff going on?
Pretty much.
Yeah, looking forward to meeting you guys on Monday, right? We're gonna meet a week from today. So,
That's right.
hey, you guys got any questions on anything before I go over question 8 for the report?
Yeah, for the previous parts of the lab where it says to have like page 1 be, our data calculated, page 2 be the formulas, all that stuff. Do you want us to have like separate pages in the same Excel file, or can we just like print PDFs essentially and submit those for each page?
Yep.
Okay, cool.
Yeah, whatever's easiest.
Got it. That's awesome.
Uh, any other questions? So let's share. Okay. Okay, so you guys are working up this electronic spreadsheet and computer graphing lab, and we talked about your report last time, and we talked specifically about items 1 through 7 on page 9 and 10 of your lab manual. But we put off 8 because I wanted to give you a little bit more time to get lectures under your belts. Now, my lecture, we have talked about the integrated rate laws. So as far as people in my lecture, you guys are now equipped with the knowledge to finish this report, namely finish item number 8 on page 10. We can go over that now, or we can go over it on Wednesday, or both. Do you guys have any preference?
Can we do both, please?
Yeah, okay, you got it. Yeah, absolutely. All right. So for number 8, it says the typed report word process to include the following items. Purpose section. This is to be 1 or 2 paragraphs explaining the purpose of this experiment. So the purpose of this experiment, there's a lot of purposes actually. One purpose is to see if you can read and follow instructions. So if it says to change the time column to the 10th place, make sure that you do that when you report it. So you have to go to the time column, and so this is, I don't know, item 1, I guess, and make sure that you have that proper, and just following all the instructions. So that's one of the purposes. Another purpose is to become familiar with the use of Excel in working up experimental data in chemistry. So, that's generating calculated data based off of given experimental data, making plots, fitting those plots to lines and things like that. So another purpose is to learn how to use Excel with a specific application to working up chemistry data. The third purpose is to make connections between the lab and lecture in terms of kinetics and the integrated rate laws. And that's really this part 8 that we haven't talked about yet. So that's what I would say for 8A. All right, that's enough for 1 or 2 paragraphs explaining the purpose. Just a reminder, if you have any questions, just holler. All right, B, number 8B, order of reaction section. This section is an analysis concerning the order of the decomp data given in the ESCG1 assignment. This is to include a statement of which type of the reaction order this data represents and why you have come to this conclusion. All right, this is where it ties to some of the stuff that you should be talking about in lecture and that we talked about in our lecture, namely using the graphical method in connection with the integrated rate laws for determining the order. Okay, so we know that for any reaction of, say, A going to B, then the rate law is going to have this form, right? R equals K times the concentration of A to the X. So in order to define completely this rate law, we need to find the rate constant and the power dependency. And the one way to do it, as you saw in lecture, is the method of initial rates, where you use tabulated data on many experiments, and you analyzed how initial concentrations affect the rate of a chemical reaction. Another way is with the integrated rate laws. And so for B, it says, what is the order? Right? So what is X? And include a statement of why you've come to this conclusion. So what you did was you followed the instructions and you made 3 plots. One concentration versus time, one the log of the concentration, and another, the last one, was 1 over concentration versus time. And when you made these plots of this data over here, I think you found something like this. So concentration versus time went like that. The log of the concentration was like this. And actually the concentration versus time was probably, sorry, like this. This one was like this. So this is not right here. Is that right? Anybody out there? Is that what you found? Can you guys hear me?
The first graph is like
Yeah, it looks like this.
no, it looks like that, but upside down or something like that.
No, no way. Look at the concentration here. See, the concentration is going down with time. So it's got to go like this. This is concentration here.
When I graphed it, it was more of, I guess, like a concave line versus having that arc. It arced down instead of arcing up.
Yeah, it's like this, right?
No, it was more of like it started high in the axis and then dipped down instead of having an arc.
Oh, it went like this.
Yes.
Oh,
Yeah.
thank you. Okay, good. All right, so anyway, this definitely wasn't linear, and this definitely wasn't linear, but this was. The log of the concentration versus time was linear. So the question is, from that, can you tell what the power dependency must be? Anybody?
It'd be the slope of the line, right?
First
I'm
order.
Yeah, I'm sorry. The power dependency is this here, the order. That's what I'm talking about. What is the or what is X?
It'd be the slope of that LN line.
Nope.
Sure.
First
Anybody?
order?
Yeah, it's first order. It's one. Now, the reason why you should know that is because you're in my lecture and we went over integrated rate laws. So in the lecture this morning, when we talked about integrated rate laws, the integrated rate law for first order looks like this. The log of the concentration equals minus KT plus ln some initial log of some initial concentration. So as we talked about this morning in our lecture, this is an infinite point function, and it says that if the rate law for a reaction has a power dependency of 1, then when you make a plot of the concentration versus time, or how concentration changes in time, it should come out as a straight line, and you could have Excel tell you what the parameters of that line are, namely M and B. Y equals mx plus b is that equation of the line. And so through an association with the integrated rate law, you have conclusively determined that X must be 1, because when you plotted the concentration versus time, which is a different integrated rate law for 0th order, this is first order. Remember, for 0th order, that relationship looked like this. And for second order, it looked like this. So if I had plotted this one over here and it came out linear, then I would conclude that X must be 2 because of association with the second order integrated rate law, but it didn't. So it's not second order. And first order did come out linear, so that's the one that I'm saying that it must be, because that's the way this experimental data behaves. It behaves like the first order integrated rate law. And the 0th order, it came out curvature. So
So are we looking for, oh, sorry.
No, go ahead.
So are we looking for linearity for the first order, or is there?
I'm looking for linearity in any one of these plots, and
Oh,
that's
okay.
going to indicate what the order is.
Okay, thank you.
Yeah, because this is telling me how the concentration changes in time, right? This is telling me here how the log of the concentration changes in time. And this is telling me how 1 over the concentration changes in time. And I know from these integrated rate laws that were derived in lecture that there's an association between the integrated rate law and the order. You get a different integrated rate law depending on the order. So in that question, then B, it says, what's the order of reaction? It's first order. And then it says, how did you come to that conclusion? I came to the conclusion because when I plotted the log of the concentration versus time, I got a linear function, and that's what the integrated rate law says should be so for first order. And so that's the answer to B. Any questions on that?
Yeah, I have a question. So, when we graphed the ln concentration versus time last time, I have like a r squared here equals,
Uh-huh.
can you remind me like where that comes from?
Yeah, the R squared value for Excel, and I think many plotting programs, is referred to as the goodness of fit criterion. And there's a formula for R squared. I don't know what the formula is offhand, but I do know that whatever that value is, the closer it is to 1, the closer that set of data is to linearity. So you can use that goodness of fit criterion, that R squared value, to tell whether one plot is more linear than another. So if I took the R squared values for all 3 of those plots, then the R squared value should be closest to 1 for the log of the concentration versus time compared to the others. And that's proof that that's the most linear, and therefore it corresponds to the integrated rate law for first order. Does that help?
Yeah, thank you.
Oh, okay. All righty. Any other questions? Okay, so we'll go on to C. All right, C says, using the appropriate equation, identify the specific rate constant K for the decomposition. Carefully explain and demonstrate how you've done the determination of K and include the appropriate units for this constant. Okay, so how do you determine K for this? Well, what you have is you have a plot, and Excel fit this to a y equals mx plus b. So m is some number. I'll call that number 1, and b is another number that Excel gives you. Now, through association with the integrated rate law for first order, I can use these values, these numbers that Excel gave me, to calculate the rate constant as compared to the slope. So what this tells me is that for first order, m equals minus k. That's for first order. First order. And for zeroth order too. Now, if the linear plot was the log of the 1 over concentration versus time, then it would be second order, and the second order equation integrated rate equation looks like this. So here I see, unlike first and zeroth order equations, this guy, the slope equals k. But here it equals minus k, which means that if Excel gives you a value, and I think it's around minus 0.07, I don't know, 36, whatever it gave you. So that equals minus K. So K equals 0.073. Or whatever it comes out to. I think it's close to that. So you see K's positive, the rate constant. And the units of the rate constant, since this is a first order plot, right? So this is the log of the concentration versus time. And the slope is associated with K, then K is going to have the same units of slope, which is rise over run. And so the rise is the y-axis, which is unitless because it doesn't have units once you take the log. So no units, rise over run. Run is the x-axis, or time in this case, seconds. And so that's the units of K. And that should make sense because it's first order. And we know that the units of K change depending on the overall order. And if it's first order, then I'm going to get units of molarity here. And I know that units of K change so that I always get rate in molarities per second. I already have a molarity, so all I need is a per second over here. Any questions on C in your report? All right, then the last thing, D, in this part, write about this experiment, blah, blah, blah. I think you can do that on your own. And so that that is it for the lab report. I guess on Wednesday, we'll have a short meeting and we'll just, I don't know, go over whatever you want. And also talk about, preparing for our first meeting in lab on Monday. Anybody have any questions?
Yeah, you said that we can possibly check out equipment on the 4th floor from the stock room
Yeah,
of the MS building. Do you know what the room number is for that room? Or is it pretty obvious when we get up on the 4th floor?
yeah, it's pretty obvious because it's right across from our lab, and our lab is MS 403.
Okay.
Yeah, it's right across the hall. And I'll be there. You could just ask me, and actually I'll go in and I'll talk to the stock room clerks and see what's up, if they have any equipment available.
Awesome. Thank you.
Sure. Any other questions? All right, then I'll wait here till everyone's gone. And thank you for your attention. We'll see you on Wednesday.